Alright, welcome back to our series on user-defined functions. If you watched our first video, you'll see that we used an example for converting rectangular coordinates to polar coordinates. And we created a user-defined function called rect2polar. Just as a reminder, we'll pull it up so you can see it. Our very first line, we have our function line. So function is the very first word that you should see. After that are our output arguments. These are the pieces of information that's going to go back to the user after the code is run. Rect2polar is the name of the function, and x and y are the inputs to the function. We've added many comments to show what this function does, what the outputs and inputs mean, and then at the end we had our equations for solving this. Now, I mentioned the importance of having these comments. If we pretend that we don't remember what rect2polar was, we do have the help option. So we can use the help option to ask MATLAB, what does rect2polar do? What does it mean? And it's going to return all of the comments that we put in there. This gives a very clear explanation of what the function does, how it works, any information that we think a user might need that might use our function. So let's actually do an example. So if we want to find r and theta, we can set it equal to rect2polar, and we can use the position maybe 3, 4. What MATLAB is going to do is it's going to return r and theta, because that's what we asked for as our outputs, r and theta. So notice that there's nothing in the workspace right now. There are no variables. So when we hit enter, r and theta have been added to the workspace. Now, one point that I want to make is just because we used r and theta in the function does not mean that we need to use r and theta when we're calling the function. So if we redo the example, and instead of saying r and theta, we call it rad and we'll call it tht, completely different variables. They do not match the name that we have in the function. We're going to get the same exact output. All we're doing is calling it something different on our end. Just like when we use the sine function or the linspace function, we can set it equal to a variable of our choosing. The same applies here. Now, one note that we mentioned at the very beginning is that user-defined functions do not share a workspace with our command window. What does that mean? Well, our command window could have variables such as a and b and c, x, y, z, whatever it may be, but our user-defined function has its own set. It only has access to the variables that we send it via the input argument. So in this example here, we have a function called sample. Our output is called out, our inputs are called a and b. A and b may exist in our workspace already. But notice that what this function is doing is it's modifying a and b. It's now declaring a as being the first element of b plus 2 times a. B is a dot times b, so we're completely changing the values for a and b. However, when we run this script, it will not change the a and b that exists in our command window's workspace. All it's going to do is give you the value for out. All our function is going to give us is whatever we list in the out function. Now, let's go back to our script real quick, our user-defined function. And a lot of what we're going to be doing as programmers specific to creating user-defined functions is we have to anticipate what our user might actually give us. Many of you have tried using a function and you've gotten the error saying too many input arguments or too little output arguments. Now, sometimes the functions can do that on their own, but we have to be prepared for any possibility. So what I'm going to show on the next screen here is a table of optional functions that we can use to improve the general quality of our user-defined function. The first two here are called narg_in and narg_out. They mean the number of arguments inputted and the number of arguments outputted. This is a variable that automatically exists when a function's run. MATLAB will know how many inputs did the user give and how many outputs did the user ask for. If we know that, we can make changes. For example, if we're expecting both x and y, but we only get one input, which one is it? Is it the x or is it the y? we can put information in here that will automatically provide a good result if we don't. But just for fun, let's test the code using only a single input. Right off the bat, we have not enough input arguments. MATLAB only has identified that one input was given, so margin was equal to 1. So maybe we try something like this. We can say if margin is less than 2, y is equal to 0. Margin is inherently already known by MATLAB. Every time this first line is generated, when rect2polar is called by the command window, MATLAB knows what margin and margout are already. So we can do something like this. We'll save the code. We'll clear our workspace. We'll try it again. And here we are. Our radial position just remains 3 because that's the only direction we have is the x value of 3, and theta is 0. So maybe our angle is meaningless, but it at least provided us with a response that we can use. Let's look at the next couple. So narg check, margin check, these are all different options that we have to verify that a certain number of inputs was given to us before we even start. Maybe it's okay if we get one input instead of two. Maybe we want MATLAB to do something else if that's the case. Let's go back to the function linspace. We have options. If we enter 2 inputs, MATLAB knows to default the number of points in the array to be 100. Whereas if we offer 3 inputs, MATLAB defaults to that third input as the number of points. There's a lot of different ways to do this. The first way is the first 2 lines here. We can create a variable called message, and we're going to set it equal to the narg check, and we're going to say 1, 2, margin. What we're doing is we're evaluating that there are between 1 and 2 variables inputted as the margin. And if, for instance, the input is not 1 or 2, then we can provide an error of that message. Another way to do it is to error of narg check of 1, 2, margin. We're just merging those 2 lines together. But my favorite is just the margin check 1, 2. You can use this single line all by itself with nothing above. What MATLAB will do is check the number of arguments inputted to be between 1 and 2. Margin check only has 2 inputs, always. Even if we want the number of inputs to always be 2, we can say margin check 2, 2. So if we go back to our code, we can add a simple line in here that says margin check 1, 2. Now MATLAB knows, before we even get into the code, that there has to be at least 1 and no more than 2 inputs.